In this video, we're going to do an example that involves systems of linear equations that involves fish, cats, and dogs. And the example says Americans own a total of about 314 million fish, cats, and dogs as pets. Now, I have to stop here. I don't think fish is a pet. I think you have to be able to pet it to be considered a pet. But anyways, I read this somewhere. There are 314 million fish, cats, and dogs as pets. The number of fish is 16 million less than the total number of cats and dogs. And there are 17 million more cats than dogs. Okay, and the question is, how many of each type of pet do Americans own? Okay, well, the first piece of information that we're given is that there are 314 million total. So that tells us that x plus y plus z is equal to 314. Okay, the number of fish, which is x, is 16 million less than the total number of cats and dogs. The total number of cats and dogs is y plus z. So if you take the total number of cats and dogs, y plus z, and you subtract 16 million, that will equal the number of fish. Okay, the last piece of information is that there are 17 million more cats than dogs. So if y is the number of cats and z is the number of dogs, the number of cats will equal the number of dogs plus 17. That actually surprises me. I'm surprised there are more cats than dogs. Maybe it has to do with the fact that some farms or some people who own cats, they have like 30 cats. But anyways, I guess there are more cats than dogs, apparently. Okay, now we want to set up a system of equations and solve our system of equations. We have a system right here, but I like to rewrite the equations so that all the variables are on the left-hand side of the equation. So I'm going to rewrite this second equation by subtracting the y and subtracting the z from both sides. And I'm going to do the same thing for the last equation. By subtracting z from both sides, we get this. Okay, so our three equations are these three here. Okay, we're going to rewrite these here as a system of equations. X plus y plus z equals 314. X minus y minus z is equal to negative 16. And y minus z is equal to 17. Okay, now our goal is basically to get a system of equations where the last equation only has one variable, say z. And then so we can solve that for z. And then the middle equation only has y and z. So once we know z, we can plug that value back into the second equation to find y. And then once we know y and z, we can plug those back into the first equation to find x. That's called back substitution. But what we have to do is get rid of this x somehow. We want there to be a 0 there. We want it to be blank. Now we already have something blank right here. That's a good sign. But we want to get this y blank here as well. So we want the last equation to just have z's. This middle equation just to have y's and z's. Okay, now I can't just erase this x and this y, so how do I get rid of them? Well, we're going to take our system of equations and we're going to get a new system by subtracting the second equation from the first. So basically we're going to take equation 1 plus negative 1 times equation 2. And that will give us a new equation 2. Okay, so our first equation is x plus y plus z equals 314, and our last equation is y minus z equals 17. But we're going to get a new equation 2. What is our new equation 2? Well, we'll take the top equation, subtract the middle one. Notice the x's go away. We're going to have a 2y, because y minus a negative y would be 2y, and then z minus negative z would be 2z. And then we have 314 minus a negative 16 would be like 314 plus 16, which is 330. Okay, so this is now our new system of equations. Notice that we're missing the x here and the x in the last equation. That's good. Now how do we get rid of the y? Well, the next thing that we can do is we can multiply this last equation by negative 2. So let's do negative 2 times equation 3. And then add to that equation 2, and that will give us a new equation 3. Okay, so we're going to get a new equation 3. The top equation is not changing. In fact, the middle equation is not changing. 2y plus 2z equals 330. But we are going to get a new last equation. How do we get it? Well, we're going to do negative 2 times the last equation plus the second equation. And negative 2 times y is negative 2y plus 2y, that's 0, right? So the y's go away. Now negative 2 times negative z would be positive 2z, plus 2z is going to give us 4z, and negative 2 times 17 is negative 34, plus 330 gives you 296. So now we have the system of equations set up exactly the way we want it. This system is equivalent to our original system, meaning it has the same solution as our original system, although it's much easier to solve now. In fact, notice the last equation we can solve very easily for z. We have 4z is equal to 296. So what we're going to do now is what's called back substitution. Okay, we're going to solve for z, first of all, by dividing both sides by 4, and we get z is equal to, I believe it's 76. So actually what, I'm sorry, 74. So actually what that means is that there are 74 million, what? Well, go back up and look. 74 million dogs. Okay, Americans own a total of 74 million dogs. Okay, now let's look at the second equation. We have 2y. So here we'll solve for y. We have 2y plus 2 times z, but we know what z is. It's 74 equals 330. So we have 2y plus 148 is equal to 330. Subtract 148 from both sides. We have 2y is equal to, let's see, what would it be? 182, I believe. I think that's right. Yeah, 182. Now divide both sides by 2. We get y is equal to 91. So what does that tell us? There are 91 million. Well, let's look at what y was. That's cats. 91 million cats. Okay, and finally we can see what z is, what x is by going back to that first equation. X plus y plus z equals 314. But we know that y is 91. Okay, we know z is 74. So we get x plus, well, that'd be 165, is equal to 314. Subtract 165 from both sides, and we get that x is equal to 149 million. So 149 million fish. That's a lot of fish. Okay, let's actually check to see, do these satisfy all the conditions? If you add 74 plus 91 plus 149, what do you get? You get 314, and that's exactly the number of fish, cats, and dogs. It says the number of fish is 16 million less than the total number of cats and dogs. Well, if you add up the number of cats and dogs, okay, 74 million plus 91 million, that's 165 million. Notice 149 million fish, that's 16 million less than the 165 million total cats and dogs. And finally, we're told that there are 17 million more cats than dogs. And notice, look, there are 91 million cats, 74 million dogs. So yes, there are 17 million more cats than dogs. So we can kind of check our answer and see if it all makes sense.